NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new.
Reports suggesting that the findings of the James Webb Telescope have undermined the case for the Big Bang.
Are galaxies older than the Big Bang? That's exactly what the James Webb Space Telescope has found. Galaxies that defy everything we thought we knew about the beginning of the universe. The Big Bang, once a cornerstone of our cosmic story, is now under attack by evidence that just doesn't fit. Could it be that our measurements have been wrong all along? Tune in as we face the possibility of a cosmic catastrophe. Galaxies too old for our universe. For almost 100 years, names like Albert Einstein, Georges Lemaitre, and Edwin Hubble have shaped our understanding of how the universe works. Einstein laid down the rules of space-time, Lemaitre introduced the Big Bang, and Hubble gave us evidence that the universe is expanding. But now, these theories are being challenged. And who's behind this cosmic shakeup? The JWST, of course. And what it has found might just rewrite the story of our universe in ways we never imagined. There was a physicist named Fritz Zwicky who also lived during Einstein and Hubble's time. He had some pretty wild ideas that were largely ignored back then. Zwicky proposed that light might get tired as it travels through space, losing energy and causing its color to shift. He called this phenomenon tired light. The idea was that light doesn't maintain a constant speed and energy, as Einstein claimed, but instead changes over time and distance. This concept never really caught on, until now that is. The tired light theory is starting to make a comeback. If Zwicky was right, and light really does change as it travels, then our measurements of cosmic distances and even the age of the universe could be totally wrong. Imagine using a yardstick that subtly changes size as you measure. You're bound to get everything wrong. This could explain why these galaxies seem to be older than the universe itself. Maybe the light we're seeing today has lost energy over billions of years, and as a result, our measurements have been misleading us. Another possibility is that the laws of physics weren't always the same as they are today. The speed of light, for instance, might have been different in the early universe. This is a huge deal because our entire understanding of space, time, and distances in the universe depends on the speed of light being constant. If that assumption is incorrect, everything falls apart. Maybe the universe isn't expanding the way we think, or maybe it's much older than the 13.8 billion years we've settled on. Some researchers, like Rendra Gupta, have even proposed that the universe could be as much as 26.7 billion years old, or even older. Scientists are in disagreement over how to deal with these findings. Some, like Michio Kaku, are excited and welcome the chance to rewrite our understanding of the universe. He thinks JWST is finally exposing the flaws in our theories, especially the contradiction between classical physics and quantum physics. Others, like John Mather, the JWST project leader, are sticking with the old theories. He believes that galaxies simply form faster than we expected, which doesn't require us to toss out the entire Big Bang theory. The Big Bang theory has been the prevailing explanation for the origin of the universe for nearly a century, but it's always had its critics. Redshift, for example, is a phenomenon where light stretches and shifts to the red end of the spectrum as it travels. This was seen as proof that galaxies are moving away from us and that the universe is expanding. These new discoveries have put scientists in a tough spot. They're arguing over who's right, with some refusing to let go of their theories, even in the face of new evidence. It's a bit like when people refuse to believe that the Earth revolves around the sun, despite all the evidence pointing to it. But the younger generation of scientists is ready to embrace the unknown. Researchers like Harvard's Rohan Naidu are excited by the new discoveries, and they're eager to explore new ideas without the baggage of the old theories holding them back. The debate over the age of the universe and whether the Big Bang actually happened isn't just academic. It affects everything we think we know about how the universe works, how it began, and where it's headed. If the universe isn't expanding uniformly, then the theories about how it will end, whether it's by a big crunch, a big freeze, or a big rip, might also be wrong. Maybe the universe won't end at all. Maybe it's infinite, and we're just a small part of something much bigger than we can comprehend. If the universe is much older than we thought, then what does that mean for our understanding of cosmic evolution? The JWST has shown us galaxies that seem far too mature for their age, which suggests that the process of galaxy formation might be much faster than we thought. But even that explanation doesn't fully account for what we're seeing. It's not just that these galaxies formed quickly, it's that they formed in a way that seems impossible based on our current understanding of physics. The more we learn, the stranger it gets. Are we missing something about these galaxies? Young galaxies defy cosmic timelines. Then there's MAX 0647JD, a galaxy that formed only 500 million years after the Big Bang, but shows a level of complexity that should have taken billions of years to develop. It's almost as if the universe had a head start, like it skipped a few steps in the process of galaxy formation. This is deeply puzzling to scientists because it suggests that our understanding of cosmic timelines might be fundamentally flawed. Another possibility is that the universe is much larger than we thought. If the universe is part of a larger multiverse, then it's possible that other universes have influenced the development of our own. This could explain why some galaxies seem so mature. They might have been affected by forces or processes from outside our universe. The idea of a multiverse is still highly speculative, but it's becoming more popular among scientists as they try to make sense of these new discoveries. Another fascinating aspect of the JWST's discoveries is the challenge they pose to the concept of dark matter and dark energy. These mysterious forces are thought to make up most of the universe's mass and energy, but we still don't really understand what they are. The JWST has shown us galaxies that seem to defy the effects of dark matter and dark energy, suggesting that our understanding of these forces might be incomplete. It's possible that dark matter and dark energy are not as dominant as we thought, or that they behave differently in the early universe. Some scientists are now considering the possibility that the universe is not homogeneous, that it's not the same everywhere. This would mean that the laws of physics might be different in different parts of the universe. If that's the case, then our current theories about the universe's origin and evolution might only apply to a small part of the cosmos. The rest of the universe could be governed by entirely different rules, which would explain why we're seeing such unexpected phenomena. The idea of a non-homogeneous universe is supported by the discovery of large-scale structures that seem to defy the standard model of cosmology. The JWST has found evidence of massive galaxy clusters and other structures that shouldn't exist if the universe is homogeneous. These structures suggest that the universe is far more complex than we thought, with regions that have evolved in very different ways. This could mean that the universe is much older and more varied than we ever imagined. The debate over the age of the universe and the validity of the Big Bang theory is far from over. The JWST has only just begun its mission, and already it's challenging some of the most fundamental assumptions about the cosmos. It's possible that as we continue to explore the universe, we'll find more evidence that supports alternative theories, whether it's a cyclical universe, a multiverse, or something entirely different. Imagine this. Scientists have spent decades thinking they knew how the universe worked, with clear steps and predictable rules. And then, along comes the James Webb Space Telescope, flipping the whole script. Suddenly, it's showing us galaxies that shouldn't even exist yet, at least not if we're following the usual cosmic timeline. Are we missing something big here? Could we be totally wrong about how the universe actually started, or what the early universe looked like? When we think of time, we imagine it flowing like a river, 1 second at a time, from the past into the future. Simple, right? Well, not so much if you look at it from a quantum point of view. Quantum physics is all about these really weird connections between particles called quantum entanglement. Think of it like two twins who feel each other's way from no matter how far apart they are. No matter where one particle is in the universe, it instantly knows what the other is doing. It's as if space and distance don't matter, something that should be impossible according to our usual way of thinking about how things work. But what if, in the early days of the universe, these quantum connections played a big role? What if everything was so interconnected that it sped up the formation of galaxies and stars? That's what some scientists are starting to wonder as they look at what Webb is finding out there. What if time was different at the start of the universe? This could change everything. A new perspective on time. Here's the weird part. Maybe time itself was different back then. We think of time as always ticking forward. Morning, afternoon, night, repeat. But at the quantum level, time doesn't behave the way we're used to. Particles can exist in multiple states at once, and time can be kind of fuzzy. Imagine a movie where all the scenes play out of order until someone finally hits the play button. That's sort of what quantum theory suggests. Until something interacts with these particles, everything is up in the air. Entanglement could mean that these interactions weren't just local, they might have been affecting the entire early universe, all at once. The idea that time might have been different in the early universe opens up all sorts of questions. What if time wasn't a neat, orderly flow like we experience now? What if it was more like a swirling mess, where past, present, and future were all mixed together? In that kind of scenario, things could happen much faster than we would expect. Galaxies could form in what seems like an instant because the usual rules of time just didn't apply yet. This could explain why Webb is seeing galaxies like GNZ11, which appear incredibly well-formed just a few 100 million years after the Big Bang. It suggests something sped things up, something that doesn't fit into our usual picture of gradual galaxy formation. Maybe quantum entanglement connected things across the early universe, creating order from chaos much faster than we thought possible. And then there's the big, mind-bending question: what is time anyway? In school, we're taught that time is a straight line that goes from past to future. But some scientists think that maybe time isn't a fundamental part of the universe at all. Maybe it's just something that emerges from deeper processes, like a side effect. If that's true, it means that during the early universe, time could have been a lot less rigid than we experience it now. Entanglement might have allowed things to happen without following our usual rules of cause and effect. Basically, the universe might have been making it up as it went along. Think about it like this. If time was fluid and undefined, then the early universe could have been a place where anything could happen, and it could happen fast. Imagine a cosmic soup where everything is bubbling and interacting in ways that are completely different from what we see today. Galaxies could form quickly because the ingredients were all connected in ways we don't fully understand yet. This idea is not totally new. Some physicists believe that space-time itself, the fabric that makes up the universe, might actually come from quantum entanglement. If that's the case, then during the first moments after the Big Bang, things like time and space could have been fluid and undefined, only taken on their more familiar forms as the universe cooled and expanded. The galaxies Webb is spotting could be leftovers of this strange quantum soup, snapshots of a time when everything was linked together in ways we're just beginning to grasp. It's wild to think that this isn't just about the past, it's also about the future. If entanglement was powerful enough to shape the early universe, it could still be influencing the large-scale structure of everything around us. Maybe the universe is still entangled in ways we don't fully understand, with connections that stretch across billions of light years. If that's true, then our understanding of what's possible could be just scratching the surface. Maybe the whole timeline thing we use is just an illusion, a useful way to think about things, but not the real story. What if the universe is more like a giant web, with everything connected in ways we can't see? Instead of thinking about galaxies and stars as separate objects, maybe we should think of them as parts of a larger whole. The James Webb Space Telescope is showing us that the universe might not be as fragmented as we thought. Instead, it could be more like a single, interconnected organism, where every part affects every other part. When one galaxy forms, it might set off a chain reaction that influences galaxies millions of light years away. This kind of connection would mean that the universe is a lot more complex and a lot more interesting than we ever imagined. Webb's discoveries have already shaken up what we thought we knew, and they're raising all sorts of questions about how connected the universe really is. If particles can influence each other across vast distances, then maybe everything's linked on a cosmic scale. Instead of a universe full of isolated galaxies and stars, maybe it's more like a single, interconnected organism, where each part affects the whole. This telescope has only just begun to show us what's out there, and it's already giving us so much to think about. By revealing galaxies that defy our expectations, it's pushing us to rethink how the universe started and what it means to be connected. Imagine the implications if everything in the universe is connected in this way. It would mean that nothing happens in isolation. Every star that forms, every black hole that collapses, every galaxy that grows, it all affects everything else. The universe would be like a massive cosmic game of dominoes, where one event sets off a chain reaction that spreads across the cosmos. This kind of connection could help explain some of the mysteries that have puzzled scientists for years, like why the universe is so uniform on such large scales. Maybe it's because everything is entangled, with distant parts of the universe influencing each other in ways we're only just starting to understand. The journey to figure all of this out is just getting started, and every discovery Webb makes brings us closer to understanding the incredible complexity of the universe. It's a reminder that from the tiniest particles making up our bodies to the vast galaxies light years away, everything is part of the same cosmic story. And thanks to the Webb telescope, we're getting a glimpse of just how deep that story goes. One where entanglement, time, and space are all part of a puzzle that's still waiting to be solved. One possibility is that these entanglements could help keep the universe stable. If everything is connected, then changes in one part of the universe could be balanced out by changes in another part. It would be like a cosmic balancing act, with the universe constantly adjusting itself to stay in equilibrium. This could mean that the universe is more resilient than we think, capable of withstanding changes that might otherwise lead to its collapse. On the other hand, entanglement could also lead to some unexpected outcomes. If the universe is so deeply connected, then a change in one part could have far-reaching consequences. Imagine if a galaxy on the far side of the universe suddenly collapsed into a black hole. If everything is entangled, then that event could set off a chain reaction that affects galaxies millions of light years away. The universe could be full of these kinds of connections, with every event having consequences that ripple across the cosmos. As we continue to study the data coming from Webb, we're likely to find even more surprises. The telescope is showing us galaxies that shouldn't exist, stars that form too quickly, and structures that don't fit with our current models. Each of these discoveries is a piece of the puzzle, helping us to build a new understanding of the universe. And at the heart of that puzzle is the idea of connection, of entanglement, time and space all being part of a single, interconnected whole. The implications of this are profound. If the universe is truly connected in this way, then it changes how we think about everything. It means that the story of the cosmos isn't just about isolated events happening in different places. It's about a complex web of interactions that links everything together. It means that we are all part of something much bigger, connected to the stars and galaxies in ways we're only just beginning to understand. Are we missing a fundamental piece of the cosmic puzzle? Or is our understanding of the universe simply flawed? Leave your opinion in the comments and don't forget to like and subscribe.